Now that we have seen reasons for using STAR CCM+ for CFD, let us see some features of this software when we extract CFD results. When we solve any CFD problem, till we see the results, the output of CFD is just numbers. In order to make sense of the numerical data, we need to see CFD data in the form of sensible results or post-processing objects. The concept of post-processing or visualization in STAR CCM+ is very efficient. The post-processing is based on the concept of parts. A part can be any entity. It can be a boundary or a plane section or an ISO surface. One can create as many parts as required. Once a part is created, it is made available for any post-processing purpose. All results to be seen are put into field functions. A field function can be temperature, velocity, pressure, etc. Once we create parts and have field function, we can plot the field function in any form on any part. The various forms of results can be contour plots, vector plots, streamlines, ISO surfaces. Apart from image or picture results, we can also have data results. Data results are in the form of fluxes, forces, force coefficient, and area or mass weight average quantities. Also, XY graphs can be plotted as results. We will see how to extract results in the results learning section of this course on STAR CCM+. We have seen the reasons of using STAR CCM+ for CFD as well as some interesting post-processing features of the software till now. From now onwards, we will learn how to use the software. So, the first step in starting to use STAR CCM+ is to launch the software. To launch STAR CCM+ software session, click on the STAR CCM+ icon in the Start menu if you are using Windows operating system. After this, the STAR CCM+ session image opens up. Then the GUI of STAR CCM+ opens up. The GUI is initially empty. If we open new file or already saved session, then the model tree and other details open up. Here we will see what are the different stages in the STAR CCM+ workflow. The first step in the CFD workflow is to import a surface. This is the CAD file or model which is used to construct the CFD model. This CAD surface is not perfect and contains many errors most of times. For this, the next step is to repair the imported surface. In this, we close unwanted holes, patch surface error, and do many more things. After this, we set or name boundary conditions. This means we name the boundary conditions parts as well as give them physical meaning. After this, we set the physics models like steady state or transient, laminar or turbulent flow, isothermal flow or heat transfer modeling. Then, the next step is to mesh the model or create grid to solve CFD equations. We need to select the meshing model for this which is appropriate for the concerned geometry. After this, we set up the solver. Various numerical methods are selected here. Then we prepare post-processing objects. After that, we press run to start the CFD calculations. Once the calculations are complete, we start to analyze the CFD results from which we need to make the design modifications or alterations. Now, we will see these individual workflow steps in detail. First, we said we need to import surface. So what exactly is this? In STAR CCM+, these are two types of surfaces or CAD imports. First is tessellated data. This consists of surface elements defined by 3 vertices. When we import this, we see surfaces consisting of tessellation or triangulations. Then we have the CAD data. Here we can import neutral formats which do not require any additional license, or we can import native data which requires CAD exchange license from third-party products. Best import is when there is consistency in maintaining names of surfaces, feature curves and parts. Next we see is that we need to repair surfaces. First, let us try to see why do we need to repair imported surfaces. Imported surfaces are not always suitable for flow solution. There are too many details in the CAD model. Whenever we import CAD file, the entire solid volume is imported. For CFD, the volume has to be closed and manifold. Also, if we have a single imported CAD model, the CAD parts must be split or combined into correct boundaries. For all these reasons, it is never possible to use the CAD model as it is for CFD. We need to perform repair operations on the imported CAD. How do we repair imported CAD surfaces in STAR CCM+? For simpler geometries, we can use the manual repair tools. But for complex CAD models, we need to use tools like Surfaces Wrapper. We will see this in detail in the geometry section of our course. Next step in the workflow is of boundary conditions. What are boundary conditions? When we do CFD in any software, we are solving equations of flow. These equations can give a solution only if they are closed by giving known conditions at boundaries. These known conditions are referred to as boundary conditions and are often given as inputs at flow boundaries. We cannot have a solution of CFD equations in the solution interior unless we provide known conditions at the flow boundaries. Hence, boundary conditions are required as input for any CFD problem. Depending upon flow physics at the boundary, we cannot use same boundary conditions at all boundaries. In CFD software, different boundary condition types are available for different boundary purposes. We have access, flow split outlet, free stream, mass flow inlet, overset mesh, pressure outlet, stagnation inlet, symmetry plane, velocity inlet, and wall. The distinct feature of STAR CCM+ software is that we define boundary conditions early, even before meshing. Why do we need to define boundary conditions so early? This is because STAR CCM+ takes into account the boundary type when generating the mesh. Hence, the information of boundary conditions is needed even before mesh setup. Next, we set up the mesh procedure. Here, we use two types of meshing models. First is the parts-based meshing and other is the region-based meshing. Mesh setup can be done on geometry parts as well as regions. We will see all this in detail in the meshing section of our course. In STAR CCM+, there are various mesh generation models and methods. Here, we will see a glimpse of those. When we generate mesh in STAR CCM+, we can use three methods: the continua-based method or the operations method or the mixed method. In the continua-based method, the surface and volume meshing models are region-based. In the operations-based method, surface and selected volume meshing models are parts-based. While in the mixed method, surface mesher is in operation and volume mesher is in continuum and/or operation mode. We will study all this in much more detail while we learn to mesh in STAR CCM+ in our future course sections. Next, we see is that we need to set up physics models. For this, we go to Continue and right-click to select Physics Model. We have to go on selecting physics models appropriate for our problem definition. After physics model, we need to set up the solver. Most of the times, default solver settings are sufficient. We also need to use under relaxation factor for the control of the speed of the solution. We will see this in much more detail in the solver section of our course. Lastly comes the post-processing setup. The integrated analysis and visualization tools in STAR CCM+ provides live feedback on the progress of the simulation. There are distinct advantages of this. We can stop the solution at any point, adjust parameters and continue. We can also define required analysis before starting solution, so results are saved as solution runs. After we set up the post-processing object, we have to start run. While the run continues, we can view the progress of simulation run using residual objects or monitor option. Lastly, we will discuss the file structure of the software. STAR CCM+ has one file which is the .sim file, and it contains the mesh, analysis setup and results of the last iteration or time step. An additional file, .simh file, can be written which allows the user to store and reload data from previous states of the simulation. For starting new simulation, we have to go to File, then click on New Simulation. To open an existing simulation, we have to go to File, then click on Load Simulation. To save the current simulation, we have to go to the file and then click Save.